In this video, we will work through some multiple choice questions revolving around transformations. This is AP Precalculus topic 1.12. If you appreciate this content, please don't forget to hit the like button. Number 1. The function g is constructed by applying three transformations to the graph of f in this order: a horizontal dilation by a factor of 4, a vertical dilation by a factor of 3, and a vertical translation by -7 units. Which of the following equations relating g and f is correct? A horizontal dilation by a factor of 4 is going to show up on the inside as a 1/4. It's always the reciprocal of what you see here when it is a horizontal dilation. 1/4 x is the same as x over 4, so it can't be a or b. A vertical dilation by a factor of 3 is going to show up in the front as a big old 3. So still it could be C or D. A vertical translation by -7 units is going to show up here on the end as a -7. So the answer is C. Number 2, the function k is constructed by applying three transformations to the graph of h in this order: a horizontal dilation by a factor of 1/3, a vertical dilation by a factor of 2, and a vertical translation by 4 units. Which of the following equations relating k and h is correct? A horizontal dilation by a factor of 1/3 will show up right here as a 3. These are always the reciprocal. So right there we've narrowed it down to either B or D. A vertical dilation by a factor of 2 shows up in the very front, and that just is 2. It doesn't make the reciprocal or anything. So that's going to narrow it down to the answer of D. We also have the vertical translation by 4 units, which would show up on the end as a +4, but they all had that, so that didn't really help us anyway. Number 3, the function p is constructed by applying three transformations to the graph of m in this order: a vertical dilation by a factor of 5, a reflection over the x-axis, and a horizontal translation by -2 units. Which of the following equations relating p and m is correct? A vertical dilation by a factor of 5 is going to show up in the very front as a 5. A reflection over the x-axis shows up in the very front as a negative sign. So now we have a -5. That now eliminates option A and option D. Next we have a horizontal translation by -2 units. A horizontal translation will show up on the inside of the function as an addition or a subtraction. Horizontal transformations are always the opposite of the way they look. So a horizontal translation by -2 will actually show up as x plus 2 right here. So that actually narrows it all the way down to option C. Number 4, the graph of y equals f of x, consisting of 3 line segments, is shown above on the closed interval from -3 to +3. Let's see, f of x is the one on the left. The graph of y equals g of x is the result of transforming the graph of f. Which of the following gives the transformation from f to g? So from this function to this function. Looking at the options, I see only translations. I see horizontal translations, which will shift the graph left or right, and I see vertical translations, which will shift the graph up or down. There are no dilations, so the shape of the graph remains the same. Let's track what happens to the endpoint on the right, which begins at 3, 2. So 3, 2 is right here. But that endpoint ends up right here. So that means it has a horizontal translation of 2 and a vertical translation of 1. A horizontal translation by +2 will show up as f at x minus 2, on the inside. So that narrows it down to either A or C. So B and D are out. The vertical translation by 1 will show up as a +1 on the end. That means that C is the answer. Number 5 is similar to number 4, so I won't read all of the directions. Again, we are transforming f to come up with function g. And we are looking for the expression that will give you function g. What transformations will turn function f into function g? I noticed that function f goes down and then up and then down, while function g goes up and then down and then up. So there's some type of a reflection going on here. But is it a reflection over the x-axis? Is it turning upside down like this? Or is it a reflection over the y-axis? Is it flipping horizontally like this? Let's track this piece of the graph. Notice how if you look at the slope, it goes down 4 over 2. I think I'll write a -4 over 2 on it. On the other hand, the orange part of the graph goes down 3 over 2. So this is like -3 over 2. Let's compare that to what's happening to these two arms so we can match them up. After the transformation, this segment has a slope of 4 over 2, while this segment has a slope of 3 over 2. Even though the signs changed because of the reflection that happened, we can still tell that this blue segment came from this blue segment because of the 4 and the 2, compared with the 3 and the 2 that the orange segments share. So notice that the blue and the orange did not change sides. So that means we are looking at a reflection over the x-axis. It must have flipped upside down. It did not flip side to side. So a reflection over the x-axis always shows up as a negative sign out in the very front. And really only one of these options has that. So the answer has to be B. Number 6, the tables above give values of f and g at selected values of x. The graph of y equals g of x is the result of transforming the graph of f. Which of the following could be the transformation from f to g? So we're going from here to here. Let's pick a pair of corresponding x values to compare. So -2 is becoming -5 somehow. Let's focus on a corresponding pair of x values. The -2 will become a -5. These are x values, so we are talking about a horizontal transformation of some kind. And looking at the options, there are only horizontal translations. So, a horizontal translation by what? For -2 to become a -5, we had to subtract 3. So we need a horizontal translation by -3. But that is going to show up as f at x plus 3 in a function. So that narrows it down to either C or D. A and B are out. Now let's focus on a corresponding pair of y values. 4 is becoming 6. So this will be some type of a vertical translation. The y values are increasing by 2, so this will be a vertical translation by +2. This will show up on the end of the function as a +2, so the answer is D. Number 7. The tables above give values of f and g at selected values of x. The graph of y equals g of x is the result of transforming the graph of f. Which of the following could be the transformation from f to g? So we are again going from here to here. Look at how -3 transforms into +3. This could be a horizontal translation by 6, since we're adding 6 from -3 to 3, which would show up as x minus 6, so maybe the answer is B. Or it could be a reflection over the y-axis, because that would also map negative 3 onto positive 3. Let's look at another pair of values. From 2 to negative 2. Is this a horizontal translation by 6 or a reflection over the y-axis? This is not a horizontal translation by 6. From 2 to negative 2, this would be a horizontal translation by negative 4. So it's not going to be a horizontal translation by 6. However, a reflection over the y-axis would also map 2 onto negative 2. So we must be looking at a reflection over the y-axis. This is going to show up as a negative sign inside the function, inside the parenthesis, like we see on A or D. So we can go ahead and eliminate B and C, which do not show a reflection over the y-axis. Let's compare corresponding y values now. This 5 will transform into 10. This could either be a vertical translation by 5, because 5 plus 5 is 10, or a vertical dilation by a factor of 2, because 5 times 2 is 10. A vertical translation by 5 would show up as a plus 5 on the end. None of these have that, so it can't be a vertical translation by 5. It must be a vertical dilation by a factor of 2, which would show up as a 2 in the front. So the answer is D. I'm not going to read the directions for number 8. It is the same type of problem as the last two problems. So we are transforming f into g, and we have to pick the function that would do that. Let's start with a pair of corresponding x values. So 4 will transform into 2. This time, there is no addition and subtraction on the inside of the function, so this cannot be a horizontal translation. So that means this must be a horizontal dilation. This is a horizontal dilation by a factor of 1/2, since 1/2 of 4 would give you 2. A horizontal dilation by a factor of 1/2 is going to show up as a 2 on the inside of the function, as we see in options B and D. So that means A and C are out. The 1/2 that you can kind of see in these two functions would really correspond to a horizontal dilation by a factor of 2. These horizontal dilations are always the opposite of how they appear inside the function. Let's move on to corresponding y values, like the way this 3 transforms into a 6. This is a vertical dilation by a factor of 2. 3 times 2 is 6. A vertical dilation by a factor of 2 will show up as a 2 in the front of the function. It's not reciprocal like a horizontal dilation would be. So that's why the answer is D. Use the information below for problems 9 through 12. The function y equals f of x has domain -4 is less than or equal to x, which is less than or equal to 6, and range 0 is less than or equal to y, which is less than or equal to 10. Number 9. The graph of y equals g of x is the result of the transformation g of x equals 2 times f at x minus 3 plus 1. Which of the following gives the domain of g? The domain is the set of x values, which started off from -4 to 6. What transformations do you see here that would affect the x values? Well, we only look on the inside of the function where we see x minus 3. Because horizontal transformations are always the opposite of how they appear in the equation, this is actually a horizontal translation of 3. So we need to do x plus 3 to find the new x values. -4 will become -1. -4 plus 3. 6 plus 3 is 9. So the new domain will be from -1 to 9. So the answer is B. Number 10 is similar, but which of the following gives the range of g of x? So we are transforming the y values this time. The y values of the range went from 0 to 10 originally. Now let's search g of x for transformations that will affect the y values. Those are changes happening outside of the function, the 2 and the plus 1. So I can find new y values by doing 2y plus 1. 2 times 0 is 0, plus 1 is 1. 2 times 10 is 20, plus 1 is 21. So the new range will go from 1 to 21. So this answer is C. For number 11, we are again transforming the domain. So here are the x value endpoints of the domain, -4 and 6. Let's study the transformed function h of x, looking for transformations that will affect the x values. These will occur on the inside of the function, and all we see is this 2. This is going to be a horizontal dilation by a factor of 1/2. It's always the opposite of the way it appears for horizontal transformations. So because this is by a factor of 1/2, I can find new x values by doing 1/2 times the old x values. So half of -4 is -2, and half of 6 is 3. So my new domain will be -2 to 3. So the answer is C. For number 12, we are once again transforming the range. The original endpoints of the range are y values from 0 to 10. So let's just record that again. Now let's study this transformed function for the changes that will affect the y values. These will occur on the outside of the function. So I'm looking at this -3 and the -4. So to get new y values, transformed y values, I can do -3 times y minus 4. The vertical transformations happen exactly the way they look, so you don't really need to change anything. Anyway, -3 times 0 is 0, minus 4 is -4. -3 times 10 is -30, minus 4 is -34. So the new range will be from -34 to -4. So the answer is A. Number 13, the graph of y equals k of x is the result of the transformation k of x equals 4 times f at x over 2 plus 1. The point 2, -3 on the graph of f maps onto which of the following points on the graph of k? Let us use a tiny little table. So we have this initial point 2, -3, which I'm going to record right here. Now let's look for the transformations that will affect the x values. Those will occur on the inside of the function. I see that we have a 1/2 x. X over 2 is the same thing as 1/2 x. So this is a horizontal dilation by a factor of 2. Always the opposite of the way it looks. So because this is a horizontal dilation by a factor of 2, I can get new x values by doing 2 times x. So that will turn this 2 into a 4. Now let's look for transformations that will affect the y values. These occur outside the function, and you can just kind of write these down. I see the 4 times and the plus 1, so I can get new y values by doing 4 times y plus 1. So if I apply this to this -3, 4 times -3 is -12, plus 1 is -11. So that gives us the new point 4, -11. So the answer is C. Number 14 is the same type of problem, but we have a new formula for the transformed function and a new starting point. So let's record our starting point on the little chart, 4, 1. Now let's look for the transformations that will affect x values. These will occur inside the function. This x minus 3 is actually a horizontal translation by positive 3. Horizontal transformations are always the opposite of the way they appear in the equation. So because it's really a positive 3 translation, I can find new x values by doing x plus 3. 4 plus 3 is 7. How about the transformations that will affect the y values? These will occur on the outside of the function, the negative 2 and the positive 4. You can just sort of write these down like this, negative 2 times y plus 4. Okay, vertical transformations are not the opposite, so you just write them down. So applying these transformations to this y value, we have negative 2 times 1 is negative 2, plus 4 is positive 2. So the new coordinates are 7, 2. So the answer is D. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.